You ready for this? Now, this is called 9.0 because we are beginning mod 9. Yes, we're skipping mod 8. We're beginning mod 9, but this isn't technically a part of mod 9 yet. It's kind of a prerequisite skill that we've already done to some extent, but we're just reviewing it before we get there. So, I'm going to go straight into an example. You ready? Oh, by the way, I should do some defining here for you. Rational expressions. The Franken definition of rational expressions. That's the Franken definition. Ugly fractions. They're fractions, they have x's in them, they're ugly. So this whole chapter is about fractions. Okay, so if I have a fraction such as this, what can I do to simplify this? I can divide both of these by 3, right? It's technically not 3 over 3. And we get 5 over x, correct? That would be the simplified form. Now, I don't usually write that. What I usually do is I do, okay, divide by 3, and that's 5, and that's 1. That's usually how I write it, right? Something similar like that. Or you just go right here. Why does that work? Do you know why we can do that? If I broke down 15, I could break that down to 3 times 5, yes, and 3 times x. What is 3 over 3? 1. And what is 1? I make this into a big 1. What is 1 times anything?
1.
No, 1 times anything is itself, right? So 1 times 5 over x is, guess what? 5 over x. So when we are, quote unquote, canceling something, we're canceling it because it equals 1, so it can drop out of the problem because it doesn't affect it. Does that make sense? That's what canceling is. It's finding values that equal 1, something that matches top to bottom, so that you can get it out of there to quit messing up everything else. All right? So that's how we would simplify that. There's also this thing called stating excluded values. And this is where I need to do a little bit of a reminder about fractions. Okay, so we're going to take a little trip back to 3rd grade here for a minute. You ready? So if I have something like this, how I explain that fraction to a 3rd grader is I say that means I took a pizza, I cut it into 8 pieces, and I ate 3 of those 8 pieces, right? If I have something like this, I took a pizza, I cut it into 5 pieces, and I ate 4 of those pieces. People get confused all the time with things like this versus things like this. This is I cut a pizza into 3 pieces and I ate 1 of them. This is I cut a pizza into 1 piece. How do you cut a pizza into 1 piece? You don't cut it, right? And you ate 3 of them. The person that ate 1 piece off of a pizza that was cut into 3 pieces is a very different looking person than the person who ate 3 pizzas, right? There is a big difference between 1/3 and 3 over 1. Capiche? Then we have a circumstance like this. I cut a pizza into 2 pieces and I ate nothing. Wasn't in the mood for pizza. Here's where we get an issue. I cut a pizza into 0 pieces? How do I cut a pizza into 0 pieces? Because if I don't cut it, it's still in 1 piece, isn't it? So this circumstance is an issue. Do you see why this one's okay? But this one is an issue. This one I like to call the impossible pizza situation. It's impossible. It doesn't make sense. It doesn't work out for us. So that is why we always have to be cautious whenever we have a 0 in the denominator of a fraction. It creates an impossible pizza situation, which is something that mathematically we can't deal with. Okay? So whenever we have an x on the bottom of a fraction, there is the potential for an IPS. Yeah? Because there is a value that if x was that value would give you that 0 on the bottom. How do you find out what value of x would give you that impossible pizza situation? Take the denominator and equal it to 0. Now, I usually take the original denominator and equal to 0 because even if you're starting out with something that's an impossible pizza situation, there's still an issue. So take your original denominator, set it equal to 0, and actually don't set it equal to 0. Set it not equal to 0. That's the symbol for not equal. It's just a slash through the equal sign. Why am I setting it not equal? Because I cannot have that equal 0. So I'm going to divide by 3. And I have to say that x cannot equal what is 0 divided by 3? So in this problem, yes, I get 5 over x. However, the stipulation is that x cannot equal 0. That is my excluded value. And again, why is it an excluded value? Because if x equals 0, then I have an impossible pizza situation. So we're going to be looking at two components. We're going to be doing the simplify part, and we're going to have to find out what are the values of x that give us an impossible pizza situation. Okay? So here we go. Number 2. 5, parentheses, 3 minus x all over 5x. So let's start with the canceling or the reducing part. What am I looking for? Something that equals 1, meaning something over itself. What is over itself here? 5s. So 5s cancel. Is there anything else that can cancel?
No.
Can I cancel the x?
No.
Because since this is in parentheses, it's not x. It's 3 minus x. You cannot break apart the 3 or the x if it's in parentheses. So I actually can't cancel that. The only way I could cancel x is if on the bottom it had 3 minus x also. You can only cancel things that match exactly. You can't cancel a part of a parentheses because that parentheses is making it one full unit. So I'm left with 3 minus x, and on the bottom I have x. Do I need to write the parentheses around 3 minus x in my answer? No, because if it's the only thing there, we don't need the parentheses. We only put the parentheses if there's more than just that there. So that's the simplify part. Now let's find our IPSs. Go back to your original denominator. Set it not equal to 0. Get it by itself. So what do I have? X cannot equal what? 0. Because again, 0 would make an IPS. So? All right, next one. Two x over 2x plus 10. Can I cancel out the 2 x's? No. This isn't in parentheses, but just like this one, the only reason it's not in parentheses is because there's nothing else with it, right? So technically it's in parentheses. I can't cancel out part of it. Anytime you have a binomial or a trinomial or anything further than that, you technically have parentheses. So I can't cancel out part of that. However, this binomial can be factored. What can I take out of here? A 2. And what would be left inside?
X plus 5.
Now can I cancel anything?
Yes.
Now I can cancel the 2's. What does that leave me with? X over x plus 5. Can I cancel the x's? No, because again, I have a binomial, which means it's technically in parentheses. And I can't cancel out part of a parentheses with something else. So there's the simplify part. What's the other part of the problem? Excluded values. Now, when you go back to the original denominator, my recommendation is, if you had to factor, go back to the factored form of the denominator. It's just easier. So if I go back to the factored form of the denominator, and I set it not equal to 0. Well, do you remember what happens with a number out in front? If there's no x with it, there's no answer, right? The reason why it cancels out is because if you divide by 0, I have x plus 5 is not equal to, and what's 0 divided by 2? Okay, what do I do next? Subtract 5, and I get x cannot equal negative 5. So negative 5 is the value that if I plugged it into the original denominator would give me that 0 on the bottom, or that impossible pizza situation, right? 2 times negative 5 is negative 10, plus 10 is 0. Does that make sense? Okay, I hope so. All right, you try this one. Now this one's similar to the last one in the sense that you need to factor first. Factor first, see what cancels, and then come up with your excluded values. Yes. All right, how do I factor the top? I can't factor the bottom because you can't factor a monomial. How do I factor the top? What do they have in common?
X.
What would be left inside? X squared plus 6. Can x squared plus 6 be factored any further? No. It's not a difference of squares, and it's not a sum or difference of cubes, so we're done there, right? On the bottom, I have x squared. What can cancel? X with what? One of those two x's. This is technically two x's down here. This can take away one of those two, leaving me with x squared plus 6 over x. Can I cancel out more x's? No. I have to stop right there because the binomial means I technically have parentheses. Going back to my original denominator, x squared. It cannot equal 0. So how do I get x by itself? Take the square root. Do I need to worry about plus or minus? If it wasn't 0, yes, I would need to worry about plus or minus. But with 0, there is no difference between plus 0 and negative 0. It's just 0. So x cannot equal 0. Is my excluded value always 0? No. In this case right here, wasn't 0, was it? It's not always going to be 0. Okay? All right. 15 over 5 minus 10x. What can I do? Factor the denominator. What comes out on the bottom? And then what's left inside? 1 minus 2x. Now, I know that we've spent a few mods being all particular about standard form. With these guys, don't put them in standard form. Leave them in the order in which they appear in the problem. Okay? I promise it makes life easier. What can reduce here? 15 and 5. I can divide both of those by 5, right? And it becomes 3 over 1. So I end up with 3 over 1 minus 2x. And nothing else can cancel, right? Yeah? All right. So for my excluded value, I'm coming back to the original denominator. Actually, didn't I say the factored form of the original denominator? So let's go back to the factored form. Let's come over here. 5 times 1 minus 2x. Set it not equal to 0 because we cannot have that denominator equaling 0. I'm going to divide by 5. That gives me 1 minus 2x cannot equal what? 0. Continuing on, I'm going to subtract 1, right? That gives me negative 2x cannot equal what? Negative 1. Divide by negative 2. And x cannot equal what? Positive 1/2. Positive 1/2 would make this denominator 0. And I can check that. 10 times 1/2 is 5. And 5 minus 5 does give me 0. So 1/2 is the value that would make the impossible pizza situation. Get it? All right, I got 2 more problems for you. Number 6. And this one's a little bit of a trick question. Not so much. Number 7 is the trick question. What kind of factoring do I have going on? Super X or snowflake, right? X squared plus 6x plus 9. 1 times 9 is 9. And I have 6 on the bottom. Yeah? 3 and 3. X and X. So I have x plus 3, and before we would write x plus 3 times, or x plus 3 what? Squared, right? For these guys, don't put the squared until the very end. The reason is, one of your parentheses might cancel out and the other one might not. So wait till the very end before you do that. What do I have with 9 minus x squared? I have a difference of squares, but it's a little backward, so I'm going to keep it in the order of the problem. So the 9 comes first, therefore the 3's come first. The x squared comes second, so the x squared comes second. Make one a plus and one a minus. What cancels? Isn't x plus 3 and 3 plus x the same thing? Because addition, it doesn't matter what order we write it in. So those 2 parentheses completely cancel out. That leaves me with x plus 3 over 3 minus x. Can those cancel out? No. Can any part of those cancel out? No, because since they're both binomials, they're both technically parentheses that do not match. Now, how do I find my excluded values? Go back to the original denominator, specifically the factored form of the original denominator, and set it not equal to 0. We spent a couple chapters doing this. What do I do here to find what these values are? 3 plus x is not equal to 0, and 3 minus x is not equal to 0, right? You have to set each part equal to 0. So x cannot equal negative 3. Negative x cannot equal negative 3. Divide by negative 1. X cannot equal positive 3. So what are my excluded values? X cannot equal positive or negative 3. Because if x equals negative 3, this parentheses equals 0. And what's 0 times whatever that parentheses is? 0. And if x equals positive 3, then this parentheses equals 0, and the same applies. Okay? All right. Last problem I have for you. Very similar. See if you can do this one and figure out how it's different than the one right above it that we just did. What's different about my super X? So that gives me x minus 3 and x minus 3. And the bottom? 3 minus x and 3 plus x. What cancels? Are you sure? Nothing is going to cancel with 3 plus x, right? That guy's guaranteed to be in my answer, right? What I'm going to talk to you for a minute about is this right here. Those don't match exactly, right? One of them has a negative 3 and a positive x. The other one has a positive x, or a positive 3 and a negative x, right? They're similar, but opposite. If you were to factor this, in the sense of if you were to take a negative 1 out, negative 1 times what gives you positive 3? Negative 3. And negative 1 times what gives you negative x? Positive x. Is this now the same as this? Yes, because it has a negative 3 and a positive x. So I can get these to cancel out if I do what? Factor out a negative 1. So those two can cancel. Where do I put the negative 1? Well, typically you'll see it put out in front. So you'll have negative x minus 3 on top, 3 plus x on the bottom. So you can cancel those opposites if you remember that they cancel to negative 1 instead of positive 1. Why didn't the addition ones cancel out like that? Because addition is what we call commutative, just like multiplication. 3 plus 5, 5 plus 3 means the same thing. Subtraction is not commutative. 5 minus 3 is not the same as 3 minus 5, which is why we end up with that negative thing there. So that's what I wanted to show you on that guy. If I go back to the factored denominator, isn't the factored denominator exactly the same as the factored denominator from there? Yeah. So what are my excluded values? They'd be the same, right? Because it's the exact same denominator as up here. So the excluded values would still be x cannot equal positive and negative 3. So? All right. Your homework is posted on Google Classroom. Happy studying.